Alright, so in this video we're going to look at this concept of repetition, also known as looping. So let's get started. Okay, so let's talk a little bit about this idea of iteration, because you'll often hear this term in conjunction with repetition and looping structures. And basically what iteration means is it's the act of repeating something. So when we talk about repetition or looping, we're wanting to repeat some particular operation or set of instructions. So for instance, we may have a list of contacts in our cell phone. We may be interested in doing the same set of operations to each one of these contacts here. And so we can think about iterating over each contact and repeating some particular operation. So we'll do the same operation of Bob, Charlie, Chris, and Rachel. Maybe it's simply just updating their area code. Maybe the area code changed for each one of these contacts. Another example that we may look at, and it may be a little bit easier to grasp, is this idea of iterating over each pixel in an image. And so when we talk about a pixel or a picture element, it's just simply a little dot that's composed of some color. So you could take a particular image that was originally color and you could iterate over each single pixel, and they're very, very small dots, right? So we could go through each one of these pixels and do some sort of transformation, some sort of calculation where we change some particular color to its grayscale equivalent, so ranging from white all the way to black and then gray, some form of gray in between. And so this particular image here, it looks like we're halfway through the process of transforming this color photo to a grayscale photo. And so the way that occurs behind the scenes is that we have to iterate or repeat some operation for every single pixel in that picture. So this is just a couple of examples that we can think of in terms of using this idea of repetition. All right, so let's take a look at a specific example using some C++ code. So we have an example over here, and it's a fairly short example, but we can see all the parts that we've discussed dealing with the while loop. So this Boolean expression part is just simply this part right here in parentheses. So we have while, open parentheses, I, less than 100, close parentheses. So this is just our Boolean expression, the thing that we want to test to see if we can enter into the body. So all of this right here is defining the body of our while loop. And we can have our statements that we discussed before inside this open brace, close brace that defines the body. All right, so what's going on here? Basically, we have a variable I, and it's been initialized to the value of 0. So whenever we first come here to this while some condition, while I is less than 100, I is going to be 0. So I'm going to make a little bitty table over here and keep track of maybe the value of I, and also keep track of what we're outputting, because it looks like in the body of the while loop we're actually outputting something there. So initially I is going to be 0. So since I is 0 and 0 is less than 100, we'd be able to get into the body of the while loop here and execute these statements. So we'd have do a cout, and we'd have I is 0. And then we'd increment the value of I. So this time I is now 1, and we would come back. So once there's no other statements left to execute inside the body here, we'd come back to the top and test this Boolean expression again to see if I is still less than 100. And now since I is 1, it's still less than 100, and we'll come back into the body and do this statement again, except this time we'll have I is 1. And so we continue this operation, so we keep on going, and finally we would get to I being 99. So you can imagine that maybe we had just performed this statement here in which we had I was 98, and we outputted I is 98. So we just did that operation there. And then we increment I to 99. So we're looking at this case here where we just incremented I to 99, and now we're going to come back and do this test here. Is 99 less than 100? Yes, it's less than 100, so we'd have I is 99. And then what would we do? We would increment I one more time, so we'd increment I to 100, but this time whenever we come back and execute this statement here, we'd find out that 100 is not less than 100, and so we would not output this statement anymore. So it would result in us actually executing the body of this while loop 100 times. The first time we would output I is 0, and the last time we would output I is 99. And I would get incremented to 100, but you would never actually see that being printed out because that output statement is occurring before we actually do this increment. And this statement here, maybe I should have said that initially, is just equivalent to I is equal to I plus 1. So this here is just a shortcut for saying this over here, I is equal to I plus 1. So you're probably saying, oh, well, that makes maybe a little bit more sense in terms of talking about C++. You can think about maybe C++ being one more, the next iteration of C. And that would be a correct thought. So that's basically what's going on. As soon as we get kicked out, meaning that this statement is false, so I is no longer less than 100, then we would not be able to enter into the body, and we would just come down and execute this other code, whatever other code we may have there. It may turn out that there's no other code and just the program ends at that point in time. So this false over here would be associated with this other code that we would execute after the while loop. So that's basically it. The while loop's a pretest loop. We know that we have to test the Boolean condition before we can ever do the execution of the body a single time. And we'll keep on executing the body as long as this is true. Okay, so let's take a look at one of the other looping structures that's provided to us by C++, and that's the for loop. And the for loop is basically a convenient structure. So in our previous slide, we actually looked at the while loop. And in that particular while loop, we knew that we wanted to execute maybe this code 100 times. So we set up some variable here and initialized it to 0. Our loop continuation was set up so that I was less than 100, and we incremented I by 1 each time that we went through the loop. So this was actually designed where we knew that we wanted to do this 100 times. And we may want to do, if we want to do something a known number of times, as opposed to using the while loop, we can use this convenient structure called the for loop. And so we can transform all of this stuff here into what we have over here. So here we have the keyword for, open parentheses, then a bunch of stuff, close parentheses. And this is what we call the for loop header. So this is simply the for loop header. And the for loop header has 3 parts to it. The very first part that we see here before the semicolon is what we call the initial statements. So this is the initial statements. And here is what we call the loop continuation condition. Abbreviate condition and continuation and condition. And then finally we have what is called the post statements. Okay. And what you'll see is we had the same sort of stuff over here with our while loop. So this initial statement here was what we had above the while loop. The loop continuation condition is just simply the same exact Boolean expression we had over here. And then finally this post statement was what we had at the very bottom of our while loop. So effectively what happens here is when we first enter into this bit of code for the for loop, we'll do whatever we have here. In this case, we're just simply initializing the variable, declaring and initializing the variable I to 0. So that only happens the first time that we come into this particular for loop. All right, so as we loop back around and test the loop continuation condition, we don't go back and reinitialize the value of I back to 0 each time through. So this is only done when we first come into the loop. Okay, so you can almost imagine it being before the loop or the for loop header, just like what we had here in terms of the execution. And then we have the loop continuation condition, same thing we had over here, and then post statements. So we can imagine this little statement here being the very last thing that gets executed inside the body. So that after we execute all the statements, in this case we only had one statement, then whatever post statement we have over here would be executed as the last thing, just as we had over here. So again, the for loop, not too different from the while loop in the sense that it's a pretest loop, meaning that we have to test this loop continuation condition before we ever get into the body here. So the for loop may execute 0 times, just like our while loop may execute 0 times. Again, this is a convenient structure. It's not actually required. We could still do all of our repetition structures, or all of our repetition needs could be fulfilled by the while loop without ever using the for loop. It's just a nice convenience that we can kind of wrap everything up here in the for loop header. And don't forget your semicolons here. So there is a semicolon here. Oops. There's a semicolon here, and there's also a semicolon here. No semicolon after the post statement, just a close parentheses. Okay, so let's take a look at the last looping structure, and that's the do while loop. Now, the do while loop is a little bit different than our while loop and our for loop in that it's a post test loop. So what does that mean? Well, if we look at our diagram over here, we'll see that we can execute the statement or statements one time before we'll ever test that loop continuation condition or that Boolean expression. So we execute the statement one time, test the loop continuation condition, and then if it's true, we'll come back and execute that statement or statements again. If it turns out to be false, then we'll go down here and execute some other code. So over here we have an example of a very basic do while loop. So we have some variable here, radius, that we've declared and initialized with the value of -1. And then we have the actual do while structure. So you see that we have this keyword do, open brace, close brace, while, and then some Boolean expression here. So you can see that we actually execute the body of the loop one time before we ever look at the condition here to see if we can execute it another time. So do this while this is true is basically the way we'd look at it. And so in this case, we would ask the user to enter in a radius, so prompt them, then read it, and then test to see if that radius was less than 0. The big idea here is we want to force the user to put in a valid radius. If they put in a number less than 0, then we know that we do not have a valid radius. We could have a radius of 0, but we couldn't have a negative radius. So this is a nice structure. So anytime that you have a situation in which you want to execute a statement or set of statements at least one time, then think about using the do while loop. In the case of knowing exactly how many times you want to execute, you probably want to think about the for loop. If you don't know how many times, and you may not even be executing the statements even one time, then think about using the while loop. So that's our basic 3 looping structures that we're going to look at here for C++. Okay, so now that we've finished looking at all the repetition structures, I wanted to briefly summarize all the control structures that we've been exposed to. And so when we first started programming, we looked at just writing one instruction after another. And this is the default case in which we just write things in sequence. And then we started looking at cases where if something was true based on some particular condition, we may execute some set of statements, else we may execute something else, or nothing at all. We also looked at multiple alternatives with the else if. So this is what we call selection. Some people will refer to it as conditional statements or decision statements, but it's all the same thing. We're just simply posing some particular question. If that question turns out to be true, we'll do something. If not, we may do something else. Or we can have multiple alternatives, as I said before. And then finally, what we've just finished looking at is this idea of repetition, being able to repeat some set of instructions over and over again. So you'll find out as we construct our programs, we'll consistently use sequence, selection, and repetition. And most programming languages support control structures that allow for us to write programs that use sequence, selection, and repetition. Okay, so let's look at our problem statement for, this will be program 5. So we want to write a program that will ask the user to input a word that is at least 5 characters in length. Once a valid word has been inputted, we want to ask the user to input a character. The program will then calculate the number of times this inputted character appears in the word and output the result. So let's go ahead and get into Eclipse. We'll write some pseudocode, and then we'll transform that pseudocode into some C++ code. And we'll also see some new things here besides just repetition structures. So let's get to it. Alright, so before we get started with writing the pseudocode, I want to talk about a few string operations provided for us through C++. So let's go ahead and declare a string variable. So we'll have string x. I'm going to initialize it to hello. So if we look at the string hello, we can identify a lot of things about it. One thing we may say is that it has 5 characters. If we were to ask how many L's does it have, or how many lowercase L's does it have, to be specific, we could say it has 2 lowercase L's. So how do we go about getting that information when we write a program in C++? Well, in order to get the number of characters or the length of this particular string, we can use a function. And the function that we can use, actually we could use 2 different functions. One is the size function, the other is the length function. They both return the number of characters in a string. So how do we go about using the size of the length function? Well, if we just simply write the name of the string, in this case x, and then use what's called the dot operator, so it's just a little dot, a period, and then specify the name of the function. We could either say size or length here, and then it would just be open paren, close paren. So this thing right here is just an operation that gets the length or the size of this particular string here. And then we could make this a statement in which we assign this value here. So this is going to return an integer value to us. So we could declare an int variable, and we'll just call it length, for lack of a better name, and assign this result to length. So let me make sure this is a statement by putting a semicolon here. So out in memory somewhere, so we'll just say over here in memory, we have length. This is just labeling some particular location in memory, and we would have the value of 5 stored at that particular memory location, since hello does in fact have 5 characters. Another thing that we may be interested in doing is retrieving a character at a particular location. And the way that we go about doing that is, again, just specifying the name of the string variable, then using the dot operator, and then specifying the name of the function, in this case at. Now the at function is interesting in the sense that we actually had to supply an argument here. And the argument that's being supplied here is actually the position of the character that we want to retrieve in the string. So if we had the string hello, and I'm going to just write it down again, each one of these characters has a particular position or index value. So the first one is 0, the second 1, third 2, the fourth one 3, and the fifth one is 4. So you can see that in this particular case, we have 5 characters here, and as characters are labeled with these values starting with 0. So if we wanted to retrieve, say, the third character in our string hello, we'd actually write 2 here, because that is the index value for the third character. So this particular operation here returns a character value. So what we can do is just simply declare a character, maybe ch, and do something like that. So this here would just simply return the value of L, the character L, and we would store it into this character ch. So somewhere out in memory we would have ch, and what would be stored there would just be a lowercase l. So these 2 functions will come in handy for program 5, the size function. Also, you could have wrote length here, so either one of these is fine, length or size. Size is a little bit shorter to write. And the at function, just simply returning a character at a particular position. One other thing that you may note about the index values here is that the last valid index for a particular string, the index is always 1 less than the length, and that's an important characteristic to remember. All right, so let's take this new information, and maybe once we finish writing the pseudocode, we can apply the size and the add function in this program 5. Okay, so it looks like we're ready to write some pseudocode. So I've already created the project folder, and I've also created the source file. So if you haven't created the project folder and source file for program 5, go ahead and pause the video now and then create the project folder and source file. Okay, so we've already copied in the problem statement here, and we know that we need to ask the user to input a word that's at least 5 characters in length. So what we're going to do is just simply say that we will ask the user to input a word. But we're not satisfied with them just inputting a word, because it may not meet the condition of being 5 characters in length. So we want to repeatedly ask them for a word. So ask the user to input a word while the word length is less than 5. I'll just write that as less than 5. And then once they've inputted a word that's of the correct length, Then we'll move on and then get a character from them. And this character is going to be the character that we're going to look for in that word and count how many times we find that character in the word. So we'll just say ask the user to input a character. All right, so once we have the character and we have the word, we can then do what? Basically at that point in time, we want to look at each individual character in that word and compare it to the character that they inputted. So we're going to say that we iterate over the word. Okay, so whenever you hear the word iterate, you need to be thinking about repetition control structures. All right, so as we iterate through that word, we want to get a character. And once we get a character from word, we want to see if the character matches the character that we're looking for. That's a bit of a long line there, but that's what we want to do. And what turns out is if that character matches, we want to do a specific operation. We want to increment some counter. So increment a counter. So that counter is just keeping track of how many times we've seen that character in that word. All right, so once we've done that, we can then say we want to output the number of times, or maybe, output the number of times the character was found in the word. And that's our basic pseudocode there. Ask the user to input a word, input a character. Basically, we'll go over the word, iterate over the word, get a character. If the character matches the character we're looking for, increment the counter, and then output the number of times the character was found, which will be stored in our counter. All right, so let's go ahead and start writing some C++ code. Okay, so let's add in our pound includes. So we need to have pound include IO stream. We also need to have pound include string, and using namespace standard. So we have our normal stuff that we've been seeing. Now we're ready to write our main function. So int main open paren close paren will be the main function header. Open brace, close brace. So we'll come down below our last pseudocode comment here and do the close brace. And then I'll select all this pseudocode and just tab in one level so it matches up with our source code that we're about to write. Okay, so how do we go about asking the user to input a word while the word length is less than 5? Well, let's just discuss how we go about asking the user to input a word. Well, we need to have a string variable, and we'll just call it word, and we'll initialize it to the empty string. And we also need to prompt the user to input what we'd like. So we'll say enter a word that has at least 5 characters. Okay. We'll make use of our endl here. And then once we've prompted them, then we can read it in by using our cin and the extraction operator, and then storing whatever they've typed in to the variable word. Okay. Now our situation is that if they input a word that's less than 5 characters in length, we want to repeat that operation. We want to keep prompting them to enter in a word. Hopefully they'll eventually enter in a word that's 5 characters in length. So we have a couple of looping structures that we can look at. We have the while, the for, and the do while. And since we know that we want to do these 2 operations here, the cout operation, the cin operation, at least one time, and possibly more than that, we probably want to use the do while. So I'll write do, open brace, and then tab all this in here, these 2 lines of code, and then have a close brace. And then we'll say while what? Well, we got to write our condition. Well, we want to repeat those operations, the cout and the cin operation, while the word length, or we can say size, so word.size, open paren, close paren. So we're making use of that function called size. while the size of the word or the length of the word is less than 5. So here we're just making use of that function that returns an integer value and comparing it to 5. Okay, don't forget the semicolon on the end. It's necessary to have a semicolon on the end of that while statement, or the do while statement. And that's basically it. We've got all the code there to get the word from the user and ensure that it's of at least of the right length. So now let's ask the user to input a character. So in order to do that, we'll have to declare a character variable. So we'll just call it maybe search ch for search character. This is the character that we're going to search for in the word. And I'll initialize that just simply to the character 0. You could really put any character here that you can find on the keyboard, just a single character though. And notice that when we write a character literal, we put it in single quotes, whereas a string literal is in double quotes. So you see that we have double quotes here. So these are very different animals behind the scenes, the character versus the string. All right, so let's prompt the user. So we'll use cout, insertion operator, enter a character, and the program will tell you how many times it appears. Let's see, appears. Get another P in there. Appears in the word. And we can just make use of our variable word here, so we can be generic in the way we write this. Okay. And maybe we'll put a period on the end here and use the endl. All right. And if you want to, you can split this up. So I'm going to move my insertion point maybe after the word tell and hit enter, and Eclipse will automatically split that word up for me. Make sure you do come back and write an insertion operator here so that that's doing what it's supposed to. Okay. So now we need to do a cn. So we'll do a cn extraction operator and then use search ch. So that we'll store it into that particular variable. And now, once we have our word and our character, we can now look at iterating over that particular word. So what does that mean? We want to be able to have the same number of iterations as we have characters in our word. So we have 3 different repetition control structures that we looked at: while, do while, and for. And we know that the for loop is used for counter control repetition, meaning we know exactly how many times we want to perform the body of that looping structure. So it sounds like the for loop is a good choice, since we know that we can get the length or the size of our word, and that will tell us how many times we need to do the comparison operations. Okay, so we'll write for int I, assignment statement 0. So this is our initial statement. We're just simply declaring a variable I set to 0. And our loop continuation condition is going to be as long as I is less than, and we can be very generic here and just say word.size, or we could say word.length. Okay, no arguments there. That was a typo briefly, but it should just be word.size, open paren, close paren, semicolon. Don't forget the semicolon. And then we can have our post statements, meaning the statement that gets executed after we've executed everything in the body. And that'll just be to increment our loop counter. So we basically define a loop counter here, and we increment the loop counter over here. Okay? So I'm going to put an open brace here and a close brace here. So all of our pseudocode is inside the body related to getting a character and then testing the match and incrementing a counter. So how do we go about getting a character? Well, we can specify the name of our variable, which was word, use the add operation, and then we can specify what position. And we could write in something like 0, and that would just simply get the first character of that word. But notice that that wouldn't change. So every time that we would go through this for loop, it would always be get the first character. We don't want to do that. We want to have something that actually changes. Well, the neat thing is that our loop counter here is initialized to 0, and it gets incremented by 1 each time through the body of the loop. So we can actually use I here. So every time we go through the body of the loop, it will increment the value of I. And you'll notice here that the last time through, The last time that we can actually get into the body of this for loop is whenever I is still less than word.size, or the length of the word. So say that our word was 5 characters in length. So the last time through, I would be 4, but that's okay because we saw that the last valid index would be 1 less than the word size. So this loop continuation condition is correct. Some of you may have thought that maybe we should do less than or equal to, but actually less than works out well because the last valid index of our string is always going to be 1 less than the size. So this is a good expression to have. Okay, so we can use that and we can just assign it to some character, maybe just the character and the variable name there is ch. And don't forget the semicolon on the end because all of our statements must end with a semicolon. So now that we have a character, we can look at testing to see if that character matches the character that we're looking for. So we'll see if our search character, so search ch, is equal to, make sure you do equal and not just simply 1 equal. 1 equal is our assignment operation, and our equal is for comparison testing to see if two things are equal to one another. Okay, so we want to test to see if our search character is equal to the character that we just extracted. And if that is the case, we'll scroll down a bit here. If that is the case, when we want to increment a counter. So we haven't declared a variable here to keep a count, but let's go back above this for loop here and just declare a counter. And in later videos, I'm going to discuss this idea of scope and local variables, and we'll figure out maybe a little bit more of why we want to declare this counter here as opposed to maybe inside of this for loop. So just go along with the ride right now, and we'll come back and explain in detail in a few videos later on. So we'll increment the counter. So we'll just say counter plus plus semicolon. So that's just the same thing as saying what? Counter is equal to counter plus 1. That's just our shortcut way of saying that. Try to make this look a little bit neater. And that's basically our for loop there, right? And whenever we go and run this program, I'll probably use the debugger so we can actually step through the for loop and see the value of I changing and look at what character we're examining. That's where the debugger really comes in to being a lot of fun, is whenever you're using repetition control structures and seeing the values of variables changing as we repeat the same instructions. All right, so now we're ready for our output statement. So let me scroll down a bit. All right, so we want to output the number of times that we found that particular character. So I'll say cout, insertion operator, the number, let's see, the number of, and I'll use insertion operator, number of whatever character it was, and we'll use maybe apostrophe s here in this string literal. So we'll get some character here, so maybe it's A's or L's or B's. That'll be expressed appropriately, so the apostrophe s there in the word, and we'll just make use of our variable word again, and then we'll say is, let me put a space here, and then we'll say we'll make use of our counter variable. Okay. Now the counter variable could be named anything. I just called it counter. You could have called it count. Maybe that would have been a better name. Okay, and then once we have that, we'll go back and make use of our new line character. Let me put a period there too. Okay, and that's pretty much our program. So not too long of a program. We made use of a do while. We got input from the user. We also made use of a for loop. And maybe after we run this program, we'll come back and check it out. Maybe we'll write this in terms of a while loop. So let's go ahead and save this, build it, and then run it. Okay, so let's go ahead and save our program, and then we'll build it. And it looks like we had one warning here. It says comparison between signed and unsigned integer expression. So if you double click on that particular warning here, it'll take you to the line where the problem was. And you may even get some more information here if you hover over this little caution warning. comparison, and it says the same thing, comparison between signed and unsigned integer expression. So it's talking about this comparison here. It turns out that word.size, this function, doesn't return a signed version of an integer. It returns an unsigned version. But we can cast it if we like to get rid of that warning. It really doesn't matter too much to have that warning, but we can cast that as an int value and save it and build it, and we should be able to get rid of that warning. Okay, so now that we've built it, we'll go ahead and run it. So let's run this thing here, see how it works. It says enter a word that is at least 5 characters in length, okay, or at least 5 characters. I'm going to enter something that's not 5 characters, maybe the word pig. And we can see that we have to enter the word again. So if we kept entering in words that were not of the right length, maybe the word tree, still not 5 characters, but if we said hello, then it should be okay. Now it says enter a character in the program. Will tell you how many times it appears in the word hello. So I'll type in L. Put an L. It says the number of L's in the word hello is 2. So it looks like our program is running as we expect. Now one thing that you may want to do is run this through the debugger just so you can see what's going on in the looping structure. Okay, so before we run our program in the debugger, I did want to make one change here. So our last line of code, at the very end, we made use of the /n new line character. I want to get rid of that and actually change it and make use of the endl. We know that the endl operation is going to flush out any characters we have immediately to the console as opposed to waiting at some time later if we had the /n. So this is a much better to have this as opposed to the /n when using the debugger. So go ahead and save that, click on build. So go ahead and build our program, and now instead of clicking on the run, click on the little bug for debug. And it should switch perspectives for us and start us at the very beginning of main, and we'll go ahead and start stepping through our program. So using our step over button, or you can also click on F6 or hit F6 to step over. So we'll step over, we see some variables coming into scope here, and we'll now step over again, and now we enter into the do while loop. So we are going to execute this set of instructions at least one time. Okay, step over a couple of times. And now we got to enter a word that has at least 5 characters. So I'm going to go ahead and enter in pig again, just so you can see that it's going to repeat this operation. So type in pig and then hit enter. And now it's going to test to see if pig, the number of characters is less than 5. It is less than 5, so we do that operation again. Okay, so we got to enter in a word. So step over a couple of times, and this time we'll type in hello. And hit enter, and now it's going to test again. And this time we'll not have to repeat that operation since this ended up being false. So since it was false, we did not repeat that operation. And now we're going to enter in a character, so go ahead and step over a couple of times. Eventually we'll get a prompt there. And now we need to enter a character, and the program will tell us how many times it appears in the word hello. So we'll enter in the lowercase l and hit enter. And now we'll initialize our counter variable to being 0. So you can see that value 0 there being associated with our variable counter. And now we're going to simply step through our for loop. So when we first come into our for loop here, it's going to initialize this variable I to being 0. So we step over, and it's also going to test this loop continuation condition. So it's going to test to see if 0 is less than 5 in this particular case, since we typed in hello as our word. So step over, so we see that I is 0. So we're able to get into the loop body here, and now we're going to get the character at the first position, so the one at the 0 position, which is going to be the lowercase h. So go ahead and do a step over. So we can see that character ch has been assigned to, or h has been assigned to the variable ch. And now we're going to do a comparison between search ch and ch, so the character that we're searching for, and the first character. So we know that that's not going to be a match, so we will not increment the counter. We will not get inside this particular if statement here. So I'll do a step over, and now we're back to the top of our for loop. And what's going to happen now is we'll increment the value of I. It'll now be 1, and we'll test to see if 1 is less than 5. which it is. So that kind of all happens in one motion if we do this step over. So I was incremented to 1, and we did test that. We were able to get inside the loop body again. We'll get the next character at the position with the index value of 1. So that's going to be E. So you can see that we have an E here. We'll do another comparison there to test E and L, see if they're the same, and they're not. So we get back to the top of the for loop here. And now we'll test to see, well, we'll first increment the value of I and test to see if the value of 2 is less than 5, which it is. So we'll get back into the loop body. You can see that I was incremented to 2 here. And now we'll get the next character. And this time, the character that we'll get is the L. So now we have the L here associated with CH. And in that case, once we do that comparison, we know that lowercase l is equal to L. And so we're going to increment our counter. So our counter will be bumped up to 1. So we found one instance of that particular character that we're looking for in the word that was typed in. So step over again, and now we're back to the top. And if we bump up the value of I this time, it's going to be 3. 3 is still less than 5. So we're able to get back into the body. We get the next character, which is another L. Okay, so we have L here. And we'll test to see if that L is the same as the thing that we're looking for, which it is. So we bump up the counter again. So the counter value is now 2. And we'll step over one more time. Okay, I is now 4. We're still able to get into the loop body, so this time we'll get the character in the last position, the index value of 4, which is the O. O is not equal to L, and we'll test one more time. This time I will be 5. 5 is not less than 5, so we drop out of that for loop there. And now we'll just simply display the output to the user. So the number of L's in the word hello is 2. And that's basically all the program. You can terminate it at this time and just clicking on the stop button, and we can switch perspectives back to our normal editing perspective.